Welcome back, everybody. Mr. Renneker here. In the second part of this lesson, we're going to still be focused on circles, but this time we're going to talk about something called the circumference of a circle. By the time you're done with this lesson, you should be able to do two main things. First, you should be able to describe or define what circumference is. Second, you should be able to find circumference given the diameter or radius of a circle. Let's go ahead and jump into this. The distance around a circle is called the circumference. We'll pause right there for a second. When we talk about the distance around a shape, in the past we would have referred to that as something called perimeter. We don't use perimeter for circles for one relatively straightforward reason. Perimeter, that's a term that belongs to polygons or figures that are going to have straight sides, and of course the circle does not. So it just gets a special term for perimeter. So when we say circumference, again, we simply mean the perimeter of a circle. Now, the ratio of a circle's circumference to its diameter is the same for every single circle. So if we were to take the circumference, or again, the perimeter, and if we were to divide that number by its diameter, which we saw in the last lesson, you're always going to get what we call pi. Now, pi is just a Greek letter. It looks like this. And even though sometimes when we hear about the number pi, it seems mystical or magical or otherwise maybe just confusing, pi is just a number. For example, if we were to start counting 1, 2, 3, 4, oops, we missed pi. Pi is really just approximated as about 3.14, or sometimes we even sneak in the fraction 22/7. So to recap, in this introduction here, we've now learned that the word circumference is really just a fancy word for perimeter of circles. We also learned that the number pi, which we use or we describe using that symbol, pi is just equal to the circumference, what we'll call c, divided by the diameter of the same circle, and more specifically of any circle. Let's see how that helps us find circumference. So circumference of a circle is equal to pi times the diameter, d, or we can also say pi times twice the radius. Those are the same thing though, because we know that diameter is equal to 2 times the radius, which is why they give us both of these algebraic versions. Circumference is equal to just pi times diameter, or circumference is equal to pi times 2r, which is equal to diameter, we know. Now, this is related to what we just saw a moment ago, and I am going to focus on this first version of our algebraic equations to make that connection. A few moments ago, we described pi as being equal to a circle's circumference divided by diameter. Now, these two equations should look similar. They have a lot of the same variables and parts and pieces, but how are they connected to each other? Well, if I were to come down here and see if I can rewrite that equation algebraically to solve for circumference, I should see the following. In order to solve this equation for circumference, I would have to get rid of or undo whatever operation is going on with the diameter here. Well, right now the equation says circumference divided by diameter, so algebraically we would undo that by simply multiplying by diameter. In a variety of ways that we have seen in the past, since we are dividing and then turning right around and multiplying, diameter is going to cancel out on the right, leaving us with just circumference. And the right would have diameter times pi, which we could also write as pi times diameter. And that's where you should see why what we learned about pi just a little bit ago is actually the same idea that we use to help us find circumference. Now, while those ideas also make sense, we're going to go just a little bit deeper to take a look at circumference and understand, well, why can I take the number pi times diameter? Why will that help me find circumference, or what we know as perimeter of the circle? Well, if we were to look at the diagram here, we see that we have this diameter that runs across the middle of the circle. And what the formula tells us is this. If we were to take the length of that diameter, however long that is, and if I were then to take that and wrap that distance around a circle, here's a diameter, and then I'd do it again and say here's another diameter. And then if I were to do it again and say here's another diameter, you can see that the diameters, they'd wrap around the circle almost 3 whole times, with just this tiny little gap left over, which happens to be about 0.14 diameters, which means that if we were to add up that perimeter, which is what we would normally do with perimeter, we would add up the sides. We would take 1 diameter plus 2 diameters plus 3 diameters plus about 0.14 diameters, which really means you'd get 3.14 diameters, which we know 3.14 is just an approximation for pi. So that's what we're really doing. Measuring the perimeter of a circle is very challenging because of those curved sides. So what we have done in mathematics is we realize that there is a special relationship between the things we can measure and the things we can't, which is where we got pi and where we got our formulas. So let's use these ideas. The C, or circumference, is equal to pi times diameter, and circumference is equal to 2 times pi times radius, to work through some examples. So we're going to go ahead and find the circumference or perimeter of some circles being given different information in both circumstances. We'll go ahead and start with part A. And part A says, find the circumference of the flying disk, use 3.14 for pi. So here in the picture, we see we've got this red disk, frisbee, if you will, with a measurement given of 5 inches. First thing we have to discern is what measurement do we have? In other words, were we given radius or diameter? I do see that this measurement starts at the center of the flying disk and goes to an edge. It is the smaller of the two measurements we can have, which means that they have given us radius. So I know that r is equal to 5. And that should also help us choose between the two formulas that we saw just a moment ago. Either C equals pi times d for diameter, or C equals 2 times pi times radius. That one's probably our best choice here because the formula uses radius and our diagram uses radius as well. It's at this point that we can simply substitute in our value here and solve for circumference. We'll take C equals, or circumference is equal to 2 times pi, but here's where and why they asked us to use the approximation of 3.14, so we know what value to plug into our formula and our calculators. And then times r, which we know is actually 5 inches. Now that we've substituted in the correct values for pi and for r, you can use a calculator, which I highly suggest to help you finish your calculations here. I'm going to take 2 times 3.14 times 5, which in your calculator should come out to be 31.4. And in this case, now we know that our circumference is actually 31.4 inches. Let's take a look at part B. Part B says, find the circumference of the watch face. This time, though, we're going to use 22/7 for pi. Looking at the diagram of the watch face, I hope you guys can see this. We have this watch, and this time they've described a measurement that is 28 millimeters long. Now, looking at the picture, it does appear that this measurement goes from one edge of the circle through the center to the opposite edge, meaning that they have given us d, or diameter, this time. That helps me because now I know for part B, I need to use the other version of our circumference formula, which is C equals pi times d for diameter. Then we'll have a formula that I can directly plug in the value that we were given. So we'll go ahead and take circumference is equal to pi times 28. But in this case, instead of using 3.14 for pi, they're asking us to use the fraction 22/7, and we'll multiply that times 28. Now, before we finish solving that, I am going to take a moment to explain why and when you might want to use 22/7. So we'll come back to finish this problem in just a moment after we clarify that. So a tip for you guys. When the radius or the diameter is a multiple of 7, it is easier for us to use that fraction of 22/7 instead of the decimal 3.14. So when they say a multiple of 7, they mean numbers like 7, 14, 21, 28, 35, 42, 40, and we can keep going on and on and on. Any multiple of 7, if you guys have that, again, as radius or diameter, it's a good idea to save you some time and frustration to use the fraction 22 sevenths. That's why we're using 22 sevenths in the problem we started just a moment ago. Let's go back to that. So here we saw that we did have a diameter of 28, which is a multiple of 7, and that's why they used the fraction. Now, I am going to encourage you guys to still use calculators, although most of your cell phone calculators or things of that nature aren't going to offer you the ability to do fraction multiplication. So I'll encourage you to do this. One, the calculators available on the Big Ideas assignments online will help you to do fractions if you'd like to use that. There are also many, many different online calculators and calculator apps that can help you do fraction operations. So make sure you explore those as well if you need to. After you do that, we will go ahead and finish 22 sevenths times 28. And you should find the circumference equals 88, in this case 88 millimeters. And that, folks, is how you find circumference, whether you're given the radius or whether you are given a diameter. Lastly, I will give you a couple of problems to try on your own if you'd like to test your understanding. And we'll take a look at those now. Here are 3 problems for you to try on your own. You guys are going to need to decide which version of our circumference formula you're going to need to use, and also whether you're going to need to use 3.14 for pi or 22 sevenths. If you're going to try these on your own, go ahead and pause the video now so you get a couple minutes to work on it, and then unpause the video when you're ready to check your solutions. All right, for number 3, they did give us a radius of 2 centimeters, so I chose to use the formula C equals 2 pi r. I went ahead and substituted in the value 3.14 because our radius was not a multiple of 7, and then I substituted in our radius of 2. After finishing the multiplication, I figured out that the circumference should be about 12.56 centimeters. In number 4, I chose to use the formula C equals pi times d because they did give us a diameter of 14 feet. I also used 22 sevenths in place of pi this time because the diameter of 14 feet is a multiple of 7. After that, I multiplied 22 sevenths times 14, and I found out that the circumference should be about 44 feet. Lastly, for number 5, I again used the formula C equals pi times d for diameter because our image did show us a diameter of 9 inches. But this time I used 3.14 for pi because 9 inches, 9 is not a multiple of 7, so I did not need to use the fraction. Then I went ahead and multiplied 3.14 times 9, and I found out that the circumference should be about 28.26 inches. Of course, if you had any trouble with those and you don't feel like you're ready for the lesson, please make sure that you contact me to see if I can offer you some further assistance. Or as always, you can go online to Big Ideas and access extra examples and tutorials there as well. To close up the lesson, we had 2 goals that we should be able to accomplish now that we are wrapping up our lesson. First, can we describe or define circumference? We should be able to identify circumference as simply being a perimeter of a circle now. Second, we needed to be able to find circumference given the diameter or the radius. We know now that if we are given the diameter, we need to go ahead and multiply pi times diameter, or if we're given the radius, we should go ahead and multiply 2 times pi times the radius. Hopefully that'll get you guys started. As always, let me know if you guys have questions, and I'll see you next time.